back in the code interview in the second queue portion. The question is implement a cube which implements create a cube with only using two stacks as your data structure. So just to reiterate, with a queue, like you can enqueue something. So it's one, and then two, and then when you dequeue something, it's just like a liner list. Then you first in, first out. Since it says zeros in first, if you dequeue this, 0 would go away. Then you're just left with 1, 2. So to do that with using only two stacks, essentially what you want to do is you always use your second stack as a checker to dequeue, and then you always enqueue to stack 1. And that's the only time you enqueue is always going to stack to N1. And if you play with it a little bit, you kind of figure out those two simple rules. It's really simple, and it ends up working. So in this case, we enqueue 0, then we enqueue 1, then enqueue 2. Now let's just say we want to dequeue. In order to do that, we have to get 0, but that's buried underneath the stack. So the first line is an if statement. If stack 2 is 0 or empty, then you just want to flip and push all of the on stack 1 on the stack 2. So so what you would do is, let's see here, yep. So, I don't want to do that. What's the button I want to do? Maybe it's this one? No. There. So you want to move 2 over, and move 1 over, and you move all of the elements over. So while stack 1 is not empty, push it over to stack 2. And when that's done, remember what we're trying to do is dequeue. So then we can get rid of 0. Get rid of 0 there. Let's just say if we wanted to dequeue again, so the if statement is stack 2, is it empty? No, it's not. So that means you just can pop off 1. But let's just say for this case we want to enqueue some more elements. So let's enqueue 3. Like I said before, all you have to do is always push. When you ever want to enqueue, you just push the stack 1. And then we want enqueue 4. So that would look like enqueue 3, enqueue 4, right? So now we want to dequeue again. So it says if stack 2 is not empty, which it is not empty, it has 2 elements, then you just remove this one. Remove the 1. Alright, let's just say we want to dequeue again. Yep. Is the stack 2 not empty? Yep, it's not empty, it has 2 in it. So we move 2. That would dequeue 2. Now let's just say we want to dequeue again. We ask us, is stack 2 not empty? No, it is not empty. So I have to do that move 4. Whoops, this doesn't look like that. Move 4 to here. Come on. There we go. And we do that whole thing while stack 1. Then you want to make sure stack 1's empty, and you pour everything to stack 2, and then you just get rid of dequeue. And as you can see, that's all you need. So it's very simple. My first approach was a little bit more logic than I thought. It was a little bit more complex. It's really simple, but it's the same thing. You always just want to pour stack 1 and flip-flop it to going back and forth, and always popping and queuing. You have to keep track of what popping queue method was called last, but that's what I first thought. As you can see, I have code here that's like 30 lines, 20 lines. It doesn't have to be that complex. So, but yeah, pretty much so your stack class just has a size attribute and a storage attribute, and then a push and a pop, and those empty methods. So like I said, yeah, it's just so now I have a new, we're trying to make a queue with 2 stacks, and has initialized with 2 stacks from upper. And then queue, like I said, it's just a one-liner. You just always push the stack 1 when you enqueue something. But when you dequeue, remember the first thing you want to check for is if stack 2 is empty or not. If it is empty, that means we want to pour all of flip-flop all of stack 1 onto stack 2. So while stack 1 size is greater than 0, we can push that into stack 2. And then when you're all done with that, you can just pop off the stack 2. But a lot of times if there's already some stack 2 here, you'll skip this if statement and you'll go straight to the return on line 71, which you'll pop off. So as you can see, we're going to make a queue, and we're going to enqueue 1, 2, 3, and then we're going to dequeue 1 and 2, and then put 4 and 5. So let's see how that looks like when we run it. As you can see, it dequeues 1, 2, and 3, and then I think you can just do another one here, print queue, show the dict of it. 1, 2, 3. Oh, never mind. You have to. Oh wait. Yeah, never mind. But more or less, as you can see, we can keep dequeuing, and I'll hit 4 and 5 later. So, and that's the logic behind that. It's very simple. It's almost how many lines of code here? 59 through 74. So it's 15 lines in Python. So also not including your stack class as well, but yeah, pretty cool.